back to Talk Universe. There were a couple of things that I didn't mention in detail, and I should have, when I was talking about the fins of minerals and the clay and the geyser spray. And I mentioned that these fins could be created by this spray. That's not exactly how the process works, so I wanted to go into that in a little more detail so people were a little more familiar with it. I mentioned that geyser spray was a significant factor in the fins. So let's talk about the fins. Where do they form? First of all, many times when the ocean bottom dries, this clay that's at the bottom that formed in layers over the many years will fracture. And these are the mud polygons we see. Now, sometimes when these polygons separate, mineral-laden water will get into the cracks between it, and it will fill those cracks with different minerals like dissolved silica or other material. And here's an example that I can show you that is very clearly an area that's been modified by water. If you look to the left of your image here, you're going to see an area up in the left corner that has some odd polygon structures and light material. I'll zoom into the left there for you. You'll notice a wall around that stone on the left, and below it you'll see a little triangle of mineral and these little boundaries of lighter material. These are the fins that are formed between the breaks in the mud, in the polygons. And here's a little markup for those of you who are visually impaired or don't follow directions well. In either case, these are the fins, and sometimes they're much thinner. Now, if we go back to the geyser eruption zone from Sol 162, you will see this. Now, that trough is where the water did flow, and you can see it's washed clean, it's just sand, and you'll see a little high tide white crust there that I mentioned. The salt is in crustone spherules, and you'll see the fins, thin little mineral fins running all up. Now let's look at the upper right, that V-shaped channel there. That's significant. In that channel, we can see, and here's a close-up, how the fins are actually fairly extensive, but they're very thin. So here's what happens. When water sprays on these constantly, I mentioned that the bedrock is actually clay from the ocean bottom. That block can soften, and it will eventually, if the spray continues, wash away, leaving nothing behind the fins. The fins aren't very strong, they're pretty weak, and let's zoom in from a slightly different angle, a little closer. You can see how the fins are extremely thin in this case, and they fractured off due to the clay behind them being washed away and the action of the water literally eating at the material, and then eventually the water pressure fracturing the fins and knocking them off. So it's a really pretty simple process, and it happens constantly. As you can see, the fragments all around. This isn't a mystery or anything. It's just the solution to a simple geological puzzle, and explaining in a little more clarity what I was getting at with the fins a little earlier. The softer layers, I mentioned that we will see layers of sediment in the bedrock. This clay, what is this clay and where did it come from? And at the bottom of any lake or ocean, the silt, the sand, the organic matter, anything that deposits in it will form layers. And if undisturbed for a long period of time, particularly if eventually the body of water dries out, this material will harden. Now, what can happen is it can be wet again later, or it may remain dry and become part of the rock, part of the sediments. In this case, you have a sedimentary rock that is formed, and those are rocks that are formed by the action of water. One qualification, there are aeolian deposits that can be made from wind. Certain types of sandstone can. But in almost all cases, it is the interaction of water with that sand that cemented it together. Not necessarily, but very often true. So an aeolian deposit is a sediment that was made basically without water. Certain types of sandstone will do that. Now, back to the layers. Why are there layers in the rock? Well, it's very simple. In the course of the year, the seasons change, the winds change, the material delivered changes. If you think about a planet being utterly lifeless and having a body of water, then you can imagine that during some of the seasons there might be windstorms or sandstorms, dust storms, and this material will deposit and then lay at the bottom, and then other material will deposit and lay at the bottom, and it's influenced by the changes of season. So if it's a very windy season, then you're going to see more sand and dust laying on the bottom in the sediment layer. And if it isn't, then you'll see finer grade material that's just washed there by the effects of water itself. Particles in rain, raindrops actually nucleate around fine dust, such as pollen, salt crystals, or literal mineral dust. And so as the rain falls, it literally delivers a thin layer of this material that lands down in the sediment and gets built up. Now on Mars, we know that there were oceans, and we're looking at the layers in the bottom of the ocean. And each of these layers, if you think about it, represents one Martian year, which is roughly 2 Earth years long. Each of these layers you can think of it as being a page in the book of mineral life of the planet. And it's been laid down in the course of a year, and then the cycle repeats the next year. So, I mentioned softer material and harder material in the layers. This is because if you have clay-like material, it may compact a little more densely than dust or sandy material. Sandy material is going to be a little crumblier, it's going to be softer. But what if you have a biosphere? It's been noted that the layers have silica in between. Well, that's an interesting finding, and one that really makes you ask a question. What would lay silica down on a cyclic basis, keyed by the seasons? Diatoms. If you have a food chain in an ocean, it all depends on the smallest, the microorganisms, the organisms that can gather the energy of sunlight and the minerals in the rain and in the ocean and turn it into biological material, and that becomes the food for larger organisms. In our oceans, that's the key, and we see it all the time. The layering of silica in between each of these layers in the sediments in Martian bedrock very likely is an indicator that those were diatoms. And during the warmer months, the diatom population would bloom, and the little bodies would drip to the bottom, and the silica silt would form a part of the layer. As the seasons cooled, the diatoms were not as plentiful, then you'd see more of the dust storm result, some sand, some grit, and some fine dust. So this process will repeat in a 2-year cycle. So each of those layers is 2 earthly years or 1 Martian year. And like I said, they're like the pages of a book. So that's really interesting. And when the geysers are erupting and sandblasting these layers, obviously the softest material will be sacrificial. It'll go first. And in between, the harder material, those layers, will stay behind and leave the corrugations that we see in the bedrock. Really very simple when you think about it. So I thought that that was something that would bear a little explanation. Mars year, as you know, is 2 Earth years long. I mentioned that. And the upshot of this is if we look at the 1-year layers in the earthly sediments, we discover something very interesting. Every month, due to the light of the moon and shifts in the tides, we have slight variations in the thickness and hardness of the material being deposited in a single layer. Now, you will find 13 of these lunation cycles, or nearly 13, in every annual cycle of layers laid down on the ocean beds or the lake bottoms. And people will say, well, why 13? Well, shouldn't there be 12? It's 12 months. Well, the word month is based on the word moon. And yes, for the most part, you're correct. But the problem here is a lunar month is actually a little more than 28 days. Guess what? There are 52 weeks in a year, and 4 times 13 is 52. So we have slightly less than 13 lunar months in a year. Go look it up, and I think you'll find something educational there. That's kind of interesting. Now, this is what's the coolest thing about this information. As we go back in time in the layers on the Earth, we find that the months were shorter in the past. Well, what would cause this? It turns out the orbit of the moon is decreasing its, its what I should say is the force of gravity of the Earth is weaker the farther out the moon goes, and the moon's orbit is growing in size, and so the force is decreasing slightly, and the orbital period is a little longer. In the beginning of the Earth's history, our days were only about between 8 and 12 hours long, depending on the geological data you look at. The Earth spun very, very rapidly, and our moon was very close. And so we had shorter months. The moon was actually going around the Earth in just a handful of days. But by stealing kinetic energy from the rotation of the Earth isn't a perfect sphere. It's a little bit lopsided inside. And that lopsidedness combs the moon out slightly, a little bit, every moment that it's going by. And so this means the moon is being flung further out from the Earth gently over the millennia. And so as this happens, the length of the month gets longer, and the length of our day gets longer too. The moon is stealing momentum from the spinning of the Earth. This is a fascinating thing. So our lunar month got longer, our day got longer, and all of this is written in the fossil record of the Earth. The geological record beneath your feet tells the story. An amazing piece of history. So now, back to water on Mars. If you really think about it, every terrestrial planet should have a water cycle, should have a water table, and that water has been created in the planet itself, the chemistry under magma. And I go on about my book, A Fossil Hunter's Guide to Mars. I've written 2 chapters in there that explain about the formation of planets and the formation of life. I lay out in very clear detail where the organic molecules come from, how they got here, and how they function. Basically, the story of the beginning of life. And what's interesting about this, these experiments were done many years ago, at the late 50s and early 60s. And it turns out that the formation of organic molecules is literally built into the laws of physics and chemistry. It's going to happen everywhere in the universe. If there's energy and there's chemistry, you're going to find the molecules of life. Whether life forms or not is another issue. But it appears to be much more common than we thought. After all, Mars was just covered with it. It's all in the oceans, as far as I can tell so far. But I don't have access to all of the information that they're discovering, and I hope that that will change over the next few months. I know the Chinese are hot on the trail right now. Let's hope that their discoveries force the issue, and we're finally brought to the point where we must admit life is common in the universe. It's certainly common in this solar system, and I may do a show specifically about that. I think that it's most important for people to understand that even though the Earth and Mars were 2 biospheres in the solar system, it's quite possible there are 3 more. That sounds unusual or not likely, but I'll do a show about that in the near future, where we should find life in our solar system. Well, this has been Talk Universe, and I really enjoy these shows, and I hope that the listeners and watchers do as well. This is our 2nd season, and I'm hoping we have many more to come. I really enjoy spreading and sharing information because I think it makes our lives better to know the facts. And I always revert back to that one saying that I really enjoy from Edwin Bach's grandmother, B.O.K. You may want to look him up. He's a fascinating fellow. Make you the world a better or more beautiful place for having lived in it. Carry that sentiment with you and remember, this is an amazing world, a fascinating world, and I hope to share some of that information with all of you. I'm Charles Schultz. This is Talk Universe.